Hello. Hello. Yeah, so today it's going to be a quite a quick video. Hopefully nobody disturbs me. Um okay. So today I want to talk about basically image optimization in NextJS, right? So we were learning about NextJS app router and basically I just want to see how far actually, like I just want to check the image optimization part. That's about it. So let's create a new uh, next app. First of all, make it a little bit big, so I'll just call it image opt. Yeah, everything should be yes, yes, yes. Okay, while this is happening, uh I should also bring, no, let it be, let it happen. Cool. So let's go inside this image optimization or image opt, and let's also do the users. I should stop it. There are a lot of things that I have secret files there, like passwords and all of that. So basically, I just want to move one image, which is a big image, from my desktop to, let's see, yeah, back here. Okay. Yeah, let me just bring up this back. Cool. So as you can see, it's just a sample image of 30 MB. Okay. Let me simply create, go inside, um, go inside the src, create assets, and get back. Simply move this sample thing to 30 MB dot jpeg. First of all that, and then move this 30 MB jpeg inside the src assets. Okay, and then we can just simply open this. All right, cool. So here we are with the assets, and this is it. So let me just simply let this be how whatever it is. Here I can just, clean everything and export default function home return image optimization. Cool. Now if we go back, I can simply run the dev and open this, and we are here, right? Cool, it is here. The reason why it's black is because in this global css we have this. I'll just simply remove this and then we should be good. Okay, cool. So it's working fine. Now what I will do, okay, right, this is now 100%. Let's simply try and bring that image here first. So rather than doing this, let's do image, next image. Okay, and this time, because this is an app router, so I am not quite sure what they have changed. So let's go here, and in the app router, pretty sure here we are the image optimization. Cool. Okay, so local images, we are using the local image, and we are using this to use local image import as image files. Okay, and then we have width and height and all of that, cumulative layout shift. Of course, this is what I want to talk about today. Let me open it. Here's what we want to talk about: image optimization. Okay, CLS, because if the image is big, there's a problem there. I'll just show you little by while. And CWV, which stands for Core Web Vitals. Hopefully nobody comes, otherwise I have to just pause it. Okay, so this is the we have to first bring this, right? So let's go and bring as src image src from assets. No, pretty sure it's here now. Okay, it's outside, and there we go. Okay, that's our image. Now here I'll just put image src. It requires, as you can see, alt drop. Okay, let's put it image 30 MB image opt. Okay, that should do it. Now let's see how it actually looks. Wait a minute. Okay, we're back. uh yeah, where were we? I think I should just pop out this chat first and make this here, right? Okay, we were in this image optimization. Cool, here we are, which is a very big image. If you look here in this inspect tab, it's actually saying the size is roughly about 1.9 MB, right? Why? Because see, first of all, I should just open this and then bring it out. That should do it. Okay, now look here. The size is 1.9 MB. Maybe I should reload it, inspect it. So the intrinsic size, right? There are 4 properties here and 5 properties that maybe that is important here, right? First is intrinsic size. That's the real size, 33840 into 1531 pixels. Intrinsic aspect ratio is that file size, it's 1.9 MB, right? And the rendered size is this. So intrinsic size is a real size. The rendered size is what our browser can display, which is this. And then we have rendered aspect ratio. Now, if I simply drop this to 50%, right? And then reload it. See, the rendered size increased. Cool. And even though the size increased, thing is, the file size remained the same, 2 MB. Okay, what about if we do not use this and like just make it like this? Rather than using this, we use the default src, and then we have to crawl back, maybe do this 30 MB dot jpeg. Alt can be 30 MB, right? Now it also demands the width and height, all of that. And see, as it also shows that using the default one can be slower lcp and higher bandwidth, blah blah blah. Okay, we'll look into it what it is. First, let's see whether it even works or not. Most likely it does not, right? Yeah, so it is not working. Why? Because it is looking at the public. So what I'll do is I'll copy this and I paste it right here for now as well. Okay, and then I'll simply go and do this. That should give us the image, right? Here we are. and this time it took some time, right? Let's pick this up. Now check the file size. The real size of this image, the 30 MB image, is 13,583 by 5,417 pixels, and the rendered size is 3,720 72 into something something, and the file size is 30.8 MB, which is bad. If what I'll do is make it even 25%. Okay, when you zoom out, the resolution increase, typically resolution increase. Just understand it that way. And this time, the as you can see, the render size goes to this. Now if you have like a 4K and all of that windows, maybe it can go beyond, but this much is it, right? But thing is, you are loading 30 MB of size. Okay, let's see what happens when I build it, right? Hopefully it builds correctly without any issue. If it will give issue, what I'll do is quick fix of disable at the top. Let's do it again. Okay, while that is happening, I'll check with some person that okay, we are done. Cool. Now let's start it. Go back, reload it. Okay, now inspect it. What we will do is we can see that this is again 30 MB. So we can go to Lighthouse first and analyze this page load. See what happens while we are doing this. The mobile score of Lighthouse is basically doing some sort of like a throttling, right? And it completely destroys the performance, obviously. And what is the performance impact here? First of all, LCP is done, right? It's 152.6 seconds as per it. There's a total blocking time as well, and thankfully there's no cumulative layout shift, but this is like bad, right? So how should we reduce it? Let's see. The way to reduce it is click on this LCP, right? And see what it says. Avoid enormous network payload, 30 MB. Okay, 30 MB. Fine. So let's start doing that one by one because we are trying to do the optimization. I will simply remove this. I will again build this, right? Remember, I did nothing. I simply replace the image tag of web standard image tag with the image tag of, I mean the image component of NextJS. Cool. So we are just going about it. Let's see. It also says you should install this for production image optimization with NextJS. The optional Sharp packages is strongly recommended. npm i sharp will NextJS will use it automatically for image optimization. Okay, we'll install it after this. Again, we will start it. We will reload it. We will inspect it. First thing that you saw that the image size shrink from 30 MB to 2 MB, and the quality also reduced to 75%. We will fix that. We don't want that quality to reduce, so make it 100. I want the quality to be 100, and let's then see the exact file size. If you look here, it is not like anything is like going bad, right? But if you're basically what should be happening is, right, your image should be as big as possible. And I mean, when I say as big as possible, I mean as good of a pixel as possible. And of course, not 30 MB, because there's a network payload and all of that. Optimization also cost you, but it should definitely be something clear, right? At least make it 4K. Fair enough, right? 4K. Okay. Now let's start it again. Go back here, reload it. Let's see what happens. What happened? Okay, it's 4.8 MB. Something is happening here. Okay, now it's coming back. It's 4.8 MB, which is fine. 30 MB, 4.8 MB. Let's say it's a 25 MB worth of reduction just by utilizing the image component of NextJS. Now let's run this lighthouse again and see what happens. Wait. Yeah, so we are back. Let's analyze it once more. Forget about the background noises if it happens. Okay, while this is happening, I cannot do. Okay, so it is loading in the mobile itself, right? We are not concerned about the desktop that much, because if mobile is good, desktop most likely becomes good anyways. Let's see whether it is being recorded or not. Yeah, it is. Cool. See what happened. From 41 we went to 65. This is a diagnostic tool. It doesn't matter much. What matters is this: from 152 seconds we went to 14 seconds. Cool. And now in the LCP we can say that this is still a problem, right? But it is still just 4 MB of a problem, right? Okay. And this, it says, was lazily loaded. Now what is that about? Well, lazily loaded simply means that since this image is on the first viewport means when your page loads, the first thing that you come across, this thing that we are seeing, is called first page load, first viewport. Okay, so this image is inside the first viewport, therefore it has to be rendered fully, and that rendering time is basically what LCP is, right? So for example, if I just show you what LCP is, we can go here, largest contentful paint element, and then you will see this. This is a network thing, TTFP, and since we are serving from local, it is not much. But eventually what happens is, if you're serving from CDN and your network is little bit of good and there's no downtime or no boot up time, let's say for wherever you are serving your images from, then this is typically low. LCP is consisted of all these 4 of the properties. TTFP is dependent on the server. Load delay is basically once you get the response from the server, how much time it takes to load the entire thing. Load time is basically the same. This will be more than 0 if you are on a real world, not loading the file from the local. Render delay is once you get everything, like once you get the response, once you get the image, how much time your browser is taking to render that element to the DOM. And this is very bad. Why? Because it is not able to, first of all, find well, how to put it, it is not able to, the image size is wrong. That's one. Even in the mobile, the image size is wrong, and we can see this by doing this, coming here, doing this, inspect, and see here the rendered size is 375, right, in terms of width, but the file that we are sending is 3840 and 4.8 megabyte, right? Which is bad, because even though the mobile does not need that huge of a file and that huge of a dimensions of a file, what is happening here is that it still is getting all of that, right? Okay, so we are back now. How should I actually go about put it here? Now what we can do is, in the performance insights, this is something that you should be looking into. Always disable the cache, throttle it to 6x, let's say, and this should be like slow 3G. This can be like no throttling, it's fine. Slow 3G, it's fine. Now simply measure the load, page load. What this will do is, the reason why we are doing it, I'll just show you why we want to do it. Let it happen. Slow 3G. Okay, the reason why we want to do it, as you can see, the FCP is 6.48 or something, and it is still being going on. This is still being loaded. So unless and until this is not loaded completely, the LCP won't show here. Cool. Let's see what happens. Okay, I think the slow 3G is way too less. This is into X playback speed. Okay, let's make it, for the sake of this tutorial, let's make it fast 3G and measure the page load again. Everything that we are doing inside the build system. I mean, once everything is built. Okay, the moment the network speed became good, FCP increased, or I mean, in terms of performance, it increased. In terms of time, it decreased. Let's go with the no throttling and let's see what happens. Measure the page load. Okay, it says the LCP is 0.95 seconds, even though in our Lighthouse it says it is 14 seconds. Why? Because Lighthouse for mobile is done on this restricted network. There's a restriction there, which is Moto G or something like that, right? Whereas this happened without any throttling. I wanted to show you this LCP thing. So let's just put it like this. Open the network tab, and can we close this? Okay. Okay. See, what happens is like here. So this is right here is the HTML that is being requested. This is the first request, which is the HTML page, right? Unless this is not here, there's no way the browser can read anything that you're requesting within the HTML document. That's number one. Cool. So then once this is loaded, we are getting this, which is font. Then we are getting the CSS. Then we are getting a bunch of JS. And finally, after that, lazily we are loading the image, right? Okay. This is one of the problem statement that Lighthouse is showing here, which is to say that the LCP image is being lazily loaded. Okay, so how can we actually change it? Well, in Next.js, what we can do is, without changing anything else, we can say the priority should be true. Okay, when we do that and we build again, Okay, we will start it again. We will come back here. We will reload the entire page. Cool. And then we will simply do this once more. All we have done is made the priority as true, right? The first time it was okay. Now it says this score just decreased. Why? Because now we are fetching this before, so it will take some time. And this has also increased. If we go to this LCP, now the problem is that the LCP image is not being lazily loaded, which is good, but this network load is still the same. Okay, so let's see what we can do, right? The first thing that we should be doing is come to this image documentation, and here we will say image sizing, right? And this is for cumulative layout shift and all of that, but there has to be something called sizes, which is this, right? So let's see. Configuration, no, let's say with the fill container, I'll just simply copy this. Okay, thing is, it says here in the images, I think there's also rendering. Yeah, here only. Priority, we have already done it. So we made it as true. So that warning went away. Okay. I think I don't need this, so I can just type this. Okay. Image sizing is here. So one more thing is that we are not including this width and height. Now thing is, I want, let's say, the width to be, the max width should be, let's say, 950, and the height should be, say, 950. It will be a square thing, but I am telling this Next.js that rather than having the 3000 something dimensions of the image, at least at max go with the 950 by 950, something like that. Okay, and I have saying key quality, let it be 100 only, and all of that is true. Cool. Let's see what this definition here does first. Okay, we will build this one more time. This is a pain. Every time you try to check the performance or improve the performance, this step is a pain. I don't know how to overcome this. You have to build it so that all the unnecessary JS and development cycle situation goes away. You know, development, tailwind, development, because those files are huge. Okay, we are back. Let's simply reload it. Inspect this. Now you see this, there's some sort of things that are happening here, which is, first of all, there's a fetch priority which is high. Now we have the width and height, and if I just hover over here, you see the intrinsic aspect ratio is decreased, as well as the intrinsic size has decreased as well, right? It is no longer like 3000 or something. Now we can also do this here and see when we did this, it is the same like mobile respective image, right? Let's reload it one more time, and I think I have to do this for 100%. So this is now 950. Inspect it. Intrinsic size has reduced a lot, and so has the rendered size. Rendered size is basically like the moment I will put it this like this, the rendered size will increase to what we have defined, 950, and height is auto. Okay, and see the file size, it has reduced even further. Now what will happen if you go to the Lighthouse and analyze this page one more time? From 30 MB we went to 5 MB approx. From 5 MB, just by giving the exact width and height, right, we went to 400 or 450 KB. Our performance improved, obviously. This decreased. It first was around 152 seconds, then it became around 14 seconds. Now it is even half. Everything else is now in green. And here's the best part. If you click on this, the red is done, but we still have some problems in the LCP section as per this tooling. Okay, render delay and all of that. Let's go about and do more thing. What did the priority did is basically because we are images in the first viewport, it is a LCP element, therefore it has to be fetched in priority. And that means if you cannot see it here, you have to see it here. What happened? If I measure the page load one more time, you will find in this performance insights, this is only available in Google Chrome for now, so there's that, but let it happen. Okay, now it is retrieving the data and all of that. Something is amiss here. See, I don't understand what's the miss here, but let me simply close this, inspect this again, make it like this. Go to this performance insight and then do this. Right, there's no throttle anywhere, so yeah, now it is working fine. Okay, now if I open this network tab and make it like this, cool, see what happened. The HTML is being loaded. This will always load first, otherwise your browser cannot crawl the HTML or the DOM to understand what exact files like font, CSS, JS, images have you requested within that HTML document. Cool. So we have to do this. Then you see the font is coming, but the image is now being loaded in parallel. This is decided by the browser when it loads in parallel, but you have given this instruction to the browser to fetch it in priority. Right, so now it understands that I don't have to wait for the JS to complete to load this. I can load it with the CSS and all of that, and then I can just render it later. Cool. And this decreases the LCP, at least in this no throttle zone. We can do this in fast 3G as well. It should work there as well. Let's measure the load. Image is also loading quickly. Why? Because the size is now 500 KB at max, and the LCP for this even in fast 3G is 4.21 seconds. Cool. And now you can see that everything is in parallel. Okay, parallel, which was not the case previously. So that's what you did with the priority flag, and the image sizes and the width and this kept reducing the image size. Okay, so here's the things observation that we can actually go about doing. We can understand, right? This image tag had 30 MB size. This image component reduced 30 MB to 4.8 MB. Let's call it 5 MB. Okay, then we said quality, this is a quality with 100. Then we said width and height specifier, that reduced the size to from 5 MB to 500 KB. Okay, then we said priority flag LCP image. That's why we need it. Okay, and what it does, fetches the image in parallel with other resources, that is CSS files, JS files, etc. Okay, now what can we do even better? Maybe we can do better. The better thing that we can do is we can specify something called sizes. We are not worried about what this is, we just want to paste it here, right? And then we will build the entire thing again. The reason why I'm doing this is very simple. We will see what happens right now. As you can see, we have 1x, right? We have something called 1x. See, 1x, 2x. This is the src set, and there are only two src set, source set, and this is our file, right? And the intrinsic size is also like greater than the rendered size, right? That's why the file size is bigger. Okay, what will happen when I did that sizes property? It will make it a little bit worse. Let's let it load. Okay, forget about this. See this, the size reduced even further, and as you can see, a lot of source set just came up here, right? For every width we have different optimized image that is being served with different intrinsic size. Now for example, now the intrinsic size will be, see, it is 1080, which is loaded, let's say in, I think I have to show you like this. For now, in this entire full width, this is the intrinsic size, 1080. What will happen if I just keep on doing this, right? And remember, we have specified the width as well, the max width 950. So nothing will change in terms of intrinsic size, right? But the rendered size, as you can see, it maxed. And if I do it like 100%, the rendered size is max. What will happen if I do it like this? Okay, let me select this, right? Inspect again. The rendered size decreased further, right? But the intrinsic size became big. See, there's a problem in terms of our settings. To fix this, there's a tool. Pretty sure there was a tool. Let me just see if I am correct. If I am correct, what is the tool called? I think they have this somewhere. Image sizing. Well, it says automatic using the static import explicitly, implicitly, and this is the sizes prop. Even though they say use fill, but you can use the sizes with you should always use the sizes, and it should be done with the width and height as well, doesn't matter. There has to be some sort of like, okay, what was that? Let me check if I remember correctly. There's a GitHub image sizes bookmark tool. Not this. Tool. NextJS. Pretty sure there's a thing called, yeah, let me check. I'm pretty sure I remember this. I have to like figure out what is the name there. If I remember correctly, There was a name. Hold on. I had noted it somewhere down the line during my job. Okay, come on. Let's see where it is. Uh, let's see. There's this tool called. Okay, let's see. It was called lint image or something like that. Wait a minute. Lint image, if I remember now. Lint image. Yeah, it was bookmarklet. Yes, this is it. So basically, I have to drag and drop it here, right? And this is a tool which is in aussie.github.io, responsible image lint. I had noted it down in my mobile, the name, thankfully. And this is it. Okay, I simply had to drag and drop it here. Now what I will do is go back to this. Okay, one thing that I will be doing is, well, let's wrap this around a div element and then make it as flex column, justify center items center. Let's see. Okay, make it build. While we are building, let's start it again, reload it. Okay, it is somewhere here, right? Which is fine. Now if I lint this image, what it what this tool does is that it will figure out a bunch of things, which will help us to finally define the this property, like the correct property right here. Okay, that's all I am concerned about. um, that source set, it will fail it, but we don't care about it because we will let the Next.js decide the source set. The only thing that we care about is the sizes thing. We have to make it good, exactly same like we want. Is it stuck? It should not be stuck. Okay, it is working fine. uh it is, while this is taking time, I think it should be done. How much time has gone? 45 seconds or something. Okay, Anything else? Okay, this says, I mean, it is a report for this, right? 0 out of 1 images passed all the checks. There's only one image, so it is failing that. And here it says the size attribute has to match with the width of the image. The size of the image doesn't match the sizes attribute, which is this. At a viewport of this, the image was 950 pixels wide instead of a specified 640. This much of a difference. The effective viewports are this, this. So anything below above this, try using this instead. Okay, so let's copy this. And by the way, this is what the NextJS image component gives, right? If we use this also, it will work, but let the NextJS decide. So we will do this. Second is that I actually don't want, like, for example, what exact width do I want? I have to think about it, right? So let's say 950 and the height should be 380. That should do it, right? 950 and the height should be 380. Now, if this is less for you, this will also be less. So this is up to you. I just chose a random width, and based on that the height is coming up. And so I'm just going to say, okay, this is the, if this is a max width, this is a max height. That's all I'm saying. And I will also say h as full. Okay, I'll do this build again. Pretty sure I shouldn't have done this, but I'll just do that and we'll see what happens. The size also decreased, by the way, just doing the sizes. Let's call it that as well. Sizes, what did this do? Well, it decreased from 500 KB, our size of image, to let's say 150 KB. Okay, and changing based on viewport. This is just a sample which is for the desktop. For the mobile, there was a mismatch. That's why it became 1.2 MB once more. Okay, we'll keep that in mind. But okay, now let's start it again. Go back here. Inspect this. And now the size is, I mean, the intrinsic size is this. File size is again 500 KB or something. The rendered size is this. Okay, rendered aspect ratio. What will happen if I am in mobile and reload this? The file size is this. Okay, and the intrinsic size is less in mobile than it was in desktop, which is exactly what we wanted. Now, can we optimize this further? Yes, we have to play with this property itself again and again. The thing is that we can again do something like say lint image, and it will keep on resizing a bunch of things. Let's see what it gives now. Does it find any problem with any sort of like image or whatever? Now it is reading about 16 images rather than previous 9. And if you look, it is basically decreasing and increasing these width, right? Okay, now this src set attribute must not be different. We can't do anything here. Okay, I can't do anything here. Why? Because this is being controlled by NextJS, so we'll let it be. But that sizes thing that we had before, that is done, right? So this is basically how you kind of like try to optimize the image as good as possible. And then you simply go to this part of Lighthouse and try to analyze it and see whether it is working or not. I mean, it's a trial and error method at this point when the sizes and all of that is involved, because it's very difficult to calculate everything. But our performance just skyrocketed in mobile. Okay, and that's exactly what we wanted. We can just remove this as well. If you look here, this is very less, and here we are. Can this be even like go slow? Maybe, but do you want it? I mean, yeah, it's fine. Let's run this one more time just to be sure, and let's do it desktop first, and we'll do that mobile as well. In desktop it should be 100 by 100, hopefully. Yeah, okay. And this is good because desktop there's no throttle in terms of speed in Lighthouse, so everything is good, right? And if this is like not red, don't bother much about it. Make sure that keep bothering about LCP as long as it is above 2.5 seconds, okay? And then you don't bother about it. The moment this becomes green, you're good to go. For most part, unless you want to go a little further, and which you can do, which is to say connect this, connect, test the optimization part with your physical device. Cool. Now let's do this one more time. While this is happening, let me just check the message. Okay, this is our mobile, and we are having some problem in terms of LCP, which is 3.1 seconds every time. But yeah, let's see what this network tab shows us in all, and reload. Okay, it is 5.28 seconds. This is the amount of transfer of resources. And if we go to fetch this, JS, we can see that this is not much, which is like 87 or something. If we like sum this all up, the problem is not here either. 2.4 KB. Image is still 500 KB. This can be even less, right? But we are using, say, WebP format already. How can it be less than that? Well, for starters, the min width can be, if we are saying this is the that is the case, so let's call it as 950. Oh, let it be. It has calculated it. Let it be. We can just remove the quality and let it be like, say, 75 if you want, right? 500 KB is good for just one image, but if there's like a lot of images, then it becomes quite bad. Pretty sure that we can do one more thing, which is to say in this Next.js configuration, here I can say images, and here I can say formats, and I can say image AIF, which is even better than WebP. So only serve these two images, these two file types. Make it build one more time. Let's see what happens. I have reduced the quality as well, and I have like inserted that thing as well, right? Let's see what happens now. It should improve even further, right? Something is definitely amiss in terms of the first load every time. Here the size is now less, 188 KB, thankfully. And maybe in mobile as well, it will be less. Why does not go here? Let's reload it one more time in mobile and let's see. Inspect. This is even less. Okay. The reason being that we have reduced it to 75 for sure. Now let's bring the quality back. Simply see what happens when we add that AVIF and WebP in the settings, and then we will also install this package, and that's about it. And then we'll build it and see what happens. Right, while that is like building, let's go here in the network tab. Pretty sure the image is now, I mean, this browser is supporting the latest one, which is AVIF. So now it is AVIF. Let's say your browser doesn't, then it will fall back to WebP, and most major browsers support till that, right? You can add JPEG, you can add PNG, but depending on what browser is what. But here we are. Okay, and this waterfall can be seen that it was waiting for the server, but the content load happened within just 500 milliseconds or 400 milliseconds, which is fine. This, I don't know why this is happening in local even, but the overall, this became even less, right? Image which was 400 or something is now just 73 KB in mobile. Here it will fetch it again. Yeah, it would have fetched it again if our server would be like running. It is not. So let's run this server, fetch it again, right? We are on fast 3G, by the way. So the image is taking some time, but even then, just by changing the format, 400, I mean, from 500 KB, it became 310 KB, right? Which is good. Now let's install the Sharp package tool, which is recommended. It says just install it. So we'll just install it and we'll do nothing. Just install it and build our system, right? So again, this was the sizes became good, changing based on viewport, right? Proper sizing, proper sizes, using linting, we get approximately like what, 495 KB, right? Let's range it around 150 KB, which was the case, to 445 KB. Then we said AVIF image settings in next config JS, it became from 73 KB, I mean both are inclusive, and it went up to 310 KB, right? Then finally installed Sharp tool. Let's see what happens now, right? Cool, let's go. Pretty sure nothing will happen that much, but yeah, nothing happened. It's the same 310 KB. And if I look into this, yeah, it's the same 310 KB, and the intrinsic size is like 1200 because that's the minimum width it is showing. If I'm here, the minimum width will definitely become less, which is 750, right? And that is good. The size also reduced to 128 KB, which is also good. So 128 KB up to 310 KB, which is fine just by this. 310 KB. Okay, this is it. Okay, now if finally we just simply remove this and let's say we make it 90 quality. Basically it defaults to 75. Let's start going a little bit down. Sometimes if the image is not good, like there's a pixelation there, so 75 I don't like it. I mean, yes, there's a problem with 310 KB, but that's now this is the only thing that is left to do, which is like reduce it. The only thing that you can do is that, like, don't take 30 MB worth of image, right? We started from 30 MB, by the way. Most likely your default image should not be more than 4 MB, 5 MB, right? That 4K images, not more than that. So let's go with start, refresh it. I should not be doing this. Let's go with the no throttle. Okay, the moment we decrease the quality, it became 248, and here it will fetch it again as 99. Okay, let's note it down. Install sharp tool quality 100. Now if we simply remove the quality to 90, it becomes 99 to what, 248. So let's call it 100 to 248 KB. Now you can see whether the image is fine or not based on your like whether it is pixelating or not, everything is fine or not, depending on the quality that you want. And if you just do nothing, which defaults to 75, and you simply then build the whole thing again, I should be changing this for sure. I mean, whatever the thumbnail here was, I have to change it because this is about image optimization and LCP and CLS and all of that. By the way, if you have seen, the CLS is always 0, so I'm not able to showcase exactly how to fix that, but the CLS problem is fixed with this, right? This fixes the CLS problem. If there's some sort of like content above and content below and your image is less, let's say your image is rectangle, I think I can while that is happening, let's start it for now. I'll just tell you what I meant. Refreshed. This is now 188 KB, right? 75. It is 75 quality, as you can see. Q is 75. You can inspect this. You can see that the Q is 75. Size is 188. Now, if I make this small, the size is 74. Let's call it round off 74. So let's copy this, make it 10, make it 75, then make it, this is 75 and this is 188. Okay, so we came from, I mean, we reduced the, what I'm saying, we optimize our image from 30 MB. And let's also do this first. Lighthouse mobile, right? It was already good. Now it is like perfect. Even this is now perfect. Okay. The moment this becomes less than 2.5 seconds, Google is going to say good job. And that's about it. This is 0. Yeah, let's talk about this. How this happens, right? So basically you can think about, like, I will open the XLE draw. This is not what you think it is. It's, if you remember yesterday's video, you understand what this is. Cool. Okay. Cool. So imagine that there's a content here in your page. I mean, let's imagine this is your page. Okay, this is your page, and there's a content here, then there's a rectangular image here, right? And maybe I can do this, I can make it like this, and then there's a content here. Cool. Now if this width, let's say this rectangle is what you need is, let's say 950 into 380. Okay, 950 into 380 is what the image that you need, but you had set 950 into 950. So initially what will happen is before the image loads, this content will be present, but then the browser will make sure that it preserves the space of 950 into 950, a square space in this viewport, right? Because it does not know the actual image size, and this content will be below. So something like that. This will be like here, and this, let's say this will be like this, and this 950 by 950 what is happening? Okay, this is how it will be, right? Let's call it this. And then what will happen is, once the image is here, it will find that the image is only this much. So this part will shrink to this much, right? And then this part will come up here. And this layout shift is called, well, layout shift. Cumulative is basically to have an, how to put it? If this is happening in one place, you can say cumulative layout shift is equal to layout shift. But if this is like, Google is capable of doing this entire thing throughout your page, right? And if it founds, let's say, anything that is having some sort of like a layout shift, any sort of flick effect, let's call it that, then it will flag it. For example, you have a font, right? Now, once the font loads, it is something else, but you have, say, Google font or something. So once everything is loaded, your font changes to, say, bold, or from this font style, it changes to this font style, right? What happened? Well, layout shift happened. See, you can see the shifting of layout now, right? That is a layout shift. What if font loads with H1, then you have put certain more styles and it became less? Layout shift. ठीक? What about normal to bold? Layout shift. Similarly, this is a layout shift. And once you define, say, this, initially we defined this, but since there was nothing up and above, and our image was like way above, so it was capable of like saying that nothing happened. But yeah, we have to define like exactly how we want, like max width, and then based on that, go to the browser and see what is the auto rendering, what is the auto height, and just supply that, right? Max to max. Okay, so we started from, just to end this video, we started from 30 MB size of worth of image when we did nothing with the image stack, which is the base image stack of HTML. The moment we just change this HTML tag to image component of Next.js, this is the size reduction. Okay, 30 MB to 5 MB. Then we supplied this width and height, 30 MB to 500 KB. Then the priority flag, this did nothing in terms of size reduction. What it did was simply LCP image warning that we have to fetch the LCP image as priority went away. Okay, cool. Then we supplied the sizes. The moment we supplied the improper sizes, we simply copy pasted this size from the next documentation. We need this size so that the linter can actually figure out the proper size. So we supplied the wrong sizes. Even then our size reduced. Okay, but then we supplied the proper sizes using linting, and then our size, I mean the larger end, again became big. Okay, this is the mobile one, this is a image desktop one. Then we simply changed the next configuration and supplied the formats. We said the first thing that the browser should be using is this format, and if this is not present, then this format. WebP is supported in pretty much all the browsers nowadays, so these two will do. Then from there, it went from like just changing this configuration at the quality of 100, it became 73 KB in mobile and 310 KB in desktop, which is still big. For us, it is still big. But by this time, at least in our page, the lighthouse and the performance insights, everything was good. The only thing that was missing or not good was LCP. So we installed the Sharp tool and it did kind of like nothing in terms of quality. It's the same. Then we reduced the quality. It became good. Then we supplied the default quality of 75. It became perfect in terms of the LCP score as well and the lighthouse score as well. Now this quality is something that you have to compromise and go back and forth. Depends on you. Remember that we went from 30 MB to this KB, and this is the entire video on image optimization in NextJS. Hope you like it. Just subscribe the video, subscribe the channel, not the video, subscribe the channel, like the video, comment if you want to know anything else about anything regarding the NextJS. And we'll continue our NextJS journey just maybe tomorrow, maybe day after tomorrow, depends on my availability and time. I'm quite busy, but yes. Cool. See you later. Bye.